There you go. Now we seem to be live. Let me just change the description as well because it didn't really work on OBS for some reason. So let me just resemble like this. Alright. So basically, angular parentheses. Which one is that? Ah, okay. This here. Cool. I mean, for some reason you can't put more done on YouTube descriptions, which is nice. And now the last step, just to put this over here. Always on top, and then we have the live chat now. Cool. There you go. So welcome everyone. I think we're all set up now. We're ready to start another day of streaming. Oh, we've already got Danajay. Hi man, how is it going? Good to see you here. Basically, as soon as I started, which is, you know, right on time. Yeah, today we're going to be looking at some more C++, I guess, right? So last time we actually stopped at the point where we had the window for OpenGL, but nothing was drawing. So I did actually do some coding in the background today, outside the stream, and I decided to switch from FreeGlut, which is the OpenGL context manager, to Qt. So essentially, what have we done now? I started with GLFW. I didn't like that because even though I used it before, and it probably was the easiest option, I couldn't really compile the code and run with the memory sanitizer because it was giving me a bunch of errors. And then we switched over to FreeGlut, which is kind of the same as GLFW. It's also a window OpenGL context manager where you can create windows for OpenGL. But again, they had some memory issues at the end, so it turns out that we did work for no reason. And yeah, I mean, and I decided to kind of switch to Qt today. And now why Qt? Well, because it does provide a lot of like windowing tools. Isn't Qt a UI manager? It's a UI manager, Danajay, but not just that though. It's a C++ framework, right? So it has UI functionality, it has multimedia functionality for audio. You can read things like PDF as well if you want, and it has a bunch of functions that can be used in general. So like it has regex, it has their own string manipulation stuff. It's a huge library, kind of like similar to Boost, I guess, but maybe a little bit smaller than that. But it's primarily for UI. You are correct. Because of that, we can create windows with it, and we can also write OpenGL. And what's cute about Qt is that it actually provides the OpenGL functions for you. It wraps those around and then provides you those functions so that I don't really have to use glue anymore. But it does have a trade-off. The trade-off is that the build now takes, I mean, the first build takes a long time, but the following builds shouldn't take any time at all. And I've already built it once with Qt, so I've already included Qt. Yeah, it's a huge library. Qt is a huge library. In fact, on my first job, when I actually worked with OpenGL, where they had a points rendering system for point cloud, it was all Qt. It was Qt and OpenGL basically. So it is a good library. It's not too bad. And it's a nice way to create programs that are cross-platform because you can compile it for Windows, Linux, and I think even Mac actually. So yeah, it's not a bad choice. But what have I done now? So basically I've copied and pasted a lot of code, and mainly the code that I've copied it from is this particular page here. So we have this document page for the Qt 5 version, the OpenGL triangle example. So I've copied and pasted it into my project. I also changed my Conan file. So we pull Qt 6, I think it is, not quite Qt 5. Qt 6 is the latest version of Qt. So yeah, we pulled that now. We removed glue, we removed glut, we removed GLFW. We don't need those anymore. And this is all that I need right now, really. So Qt is the main one here. As always, Conan just builds this. If I type in my Conan build command, which is this one here, if you can pause the video and look at it now, it's basically that. So yeah, things are just working fine. However, waiting for the folks to say you should pronounce Qt. Yeah, it should be Qt, by the way. It's my accent. I like to say Qt, but it is Qt. It's actually, I think it's a German library, right? It was created by Germans or something. But yeah, I think I did once apply for a job at Qt, or the company that oversees Qt, but I didn't go any further because it was, unfortunately didn't get a job, but it would have been a cool experience to have. But yeah, I mean, the code here is kind of just basically copied and pasted to my project line by line. With a few changes, really. I mean, one thing that I did notice is that this particular example kind of provides the OpenGL 2 functionality from the looks of it. So I can tell from the shaders down here somewhere and the way that they're calling the OpenGL functions that they may be intended for this example to be used with OpenGL 2. So I've made the changes to make it so it initializes the OpenGL 3 functions, and our context is also an OpenGL 3 context, right? Those are the changes that I've made, and I'll go over that in a second. Dana J, so Qt provides a wrapper around OpenGL, or does it come with its own OpenGL? It provides a wrapper around it. So, yeah, this is something that's important to know. OpenGL, like if you're on Linux, for example, you should have drivers that implement the OpenGL standard. So, for example, I think the most popular one is Mesa, right? Mesa is the like OpenGL library. Not only that, but also Vulkan. And what these libraries do, Glue, Qt, they basically just find the function pointers for the implementations on your machine that are already like included from the drivers, right? So it's kind of like a wrapper, but it's not really a wrapper. It just finds the pointers. But in the case of Qt, it is in fact a wrapper, because they do sometimes include extra functionality on top of OpenGL. So the way you create shaders, for example, here with like this Qt OpenGL shader program, obviously this is not OpenGL. This is you know this is basically OpenGL shaders wrapped around a Qt object. And it's nice to see you, Kelv. I forgot to say that. Welcome to the stream, brother. Bem-vindo. But yeah, I mean, right now everything does compile fine, but I don't really get the triangle. Yeah, and this is basically just a copy and paste from this project, so it's kind of making me think that they've missed something in this. We'll take a look at that in this stream. But yeah, I mean the intention here really is that I copied some of the code to this Qt abstractions library, where I'll be sort of like providing classes and things that are abstracting Qt. So such as the GL window. So the GL window is some of the code copied from here into a class, and that just provides a window object for us to work with. And you can see that this also includes or inherits from the Qt OpenGL functions class, which is kind of the class that provides that OpenGL abstraction, but the 3.3 version. In this tutorial, this is just the Qt OpenGL functions object, which is I think is version 1 or 2 of OpenGL. So I noticed that they've got this header, this class here, so I included that one instead. Wow, this abstraction in OpenGL, I can't really read the comment entirely here. In OpenGL from Qt library looks better in code readability. Yeah, it does. Yeah, that's the point of the abstractions, I guess, right? It makes it a little bit easier. So, but concepts are the same though. Like you still have to, you know, deal with shaders. You still have to deal with buffer objects and vertex attribute pointers and stuff like that. It's not really hiding it. It's just abstracting those. Vinay Sharma, hello Vinay, welcome to the stream. I think I might have 3 people at the same time watching this, which is probably a lot for me. But yeah, congratulations on 500 subscribers. Thank you very much, Vinay. Thank you for being part of it, really. One thing that I noticed that, like, as soon as I started doing some more streams, and I do enjoy doing streams because I just code on my own time anyway. It costs me nothing to have people watching as well. Is that I can kind of chat to people and not do it on my own, which is nice. And it seems like we're getting quite a lot of subscribers, which is not a bad thing. It's something I can't complain. But yeah, who knows, one day we can actually get some money off off streaming. But we're quite far from that though, quite far from that. Yeah, so if you guys are interested, I'll post this kind of tutorial here because it does explain the logic behind the functions defined, and you can see basically what which bits I had to modify. For example, I had to modify render now because I had to set, as I said, the OpenGL version to 3.3, and there was some extra code that I had to add there. But yeah, it wasn't too bad in the end. One thing I do want to know is that when I run this, you'll be able to see that I don't really get a triangle like in the tutorial, and this could be to, you know, quite a few reasons. I don't really know why now. Basically, just copied and pasted this like half an hour ago, and we're gonna debug this in the stream. Yeah, I mean, I only get a black screen here, but however, you can see that I've requested OpenGL version 3.3 here, so the core profile, but the one we actually get is 4.2, which is higher than 3.3. I'm not complaining, as long as it's at least 3.3, it's gonna work. But it's weird how this works, really. No one can beat Asahi Lino when it comes to live coding and streaming. I hope you know her. I don't really watch that many other streamers, but let's look at wait, this is not naughty, right? I'm gonna search for it on my other other screen. Yeah, right, it's not too bad, just in case I get trolled. Is this like an AI generated kind of streamer?
And let's put that up there. But
oh no.
So I need to go and get
6 hours though. Ooh, I cannot do that.
Subscribe to FFM Big Devil.
Wait, is this a real person or is it just like... It sounded like a guy, now it sounds like a girl, so I don't know. But, you know, they've got a great setup here. I wish I had something like this. Especially this like overlay here and the background. It looks really, really cool. And what are they doing? They are doing blah, 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 blah. Static C, I guess.
But this one also doesn't look like it has a sensor and it's supported.
Yeah, this is C++ still, right? I can see the namespace there. Thought it was C.
Validate.
Yeah, it looks like really heavy systems programming. So glad to see that there's people that like this though, because yeah, it's, you know, you have to be quite involved to actually keep up with the code in there, especially if you're doing some systems engineering on stream. But yeah, going back to our code, yeah, let's figure out here why this is not kind of working. Reverse engineer a GPU driver to make it run on Arch Linux at full GPU acceleration, and that's really yeah. See, I mean, I cannot do that. I would never be able to do that. So that is a full job on itself, to be honest. Maybe if I, you know, if I didn't have a full-time job on daytime, I could try something like that one day, something a bit more complex. So yeah, I mean, one of the things that I did notice is that the shaders, they are kind of, I think this is like GL2 shaders or GLSL2. Versus 2 or something. Yeah, I'm not sure. Like I'm used to well, when I did shaders, it looked the language itself looked a bit more different to this. Really, we didn't really have attributes or anything like that, or varying. I can kind of guess what these things mean. Like I'm not as you can probably tell, I don't know GLSL at all. So attribute is like some sort of like input that comes in. High precision will be something like a double, I guess, instead of a floating point. No. Yeah, I don't know, because as far as I know, OpenGL doesn't do doubles. So this will be like 32-bit floating points, I guess. Low precision, yeah, I have no idea. Maybe just like a byte long or something. But yeah, let's try and swap the shaders to what we got from the Learn OpenGL tutorial. Which, by the way, is another great website if you're trying to learn OpenGL. I remember when I was at university, I used this website all the time to kind of just like get code snippets and understand how the rendering pipeline works. And we're here again. I'm here again to, to relearn it all because, yeah, you just forget things over the years. So this is kind of like more what I guess we understand here, right? So like this is very complicated. Let's just put it into a raw string as well. So we do raw like that. There is even a learn Vulkan from the same. Yeah, dude, if you have a year of your life, do learn it. It's definitely very, more advanced compared to OpenGL, like very, very complex as well. I remember looking at a tutorial for rendering a triangle in Vulkan, and it was legit like 2,000 lines just to render a triangle, compared to OpenGL is about 200, 300 lines of code. But yeah, it's huge, dude. And you can do that comparison, by the way. If you go on Google and type, triangle rendering in example in Vulkan, you see how many lines you get compared to the same search for OpenGL. I guess it's because Vulkan, you can customize a lot more things, right? So it's, yeah. So we've got a position here. Let's see if we can get a fragment shader as well. So just that. Let's just keep it there. Back. Seems I missed part 2. Not so boring. Welcome back. Not so boring. Yeah. Part 2 was quite boring though. It was very boring. We didn't really manage to get anything done, and I actually got majorly stuck on, I guess, drawing a triangle on Glut and the memory issues that library has as well. So yeah, just skip that. Don't worry about that part. This is the good one. This is the good one because we switched everything to Qt, so we're not going to get as stuck because Qt is quite well documented and there are a lot of tutorials out there I can just copy and paste code. So let's just see this. So in the shader, basically we're saying that we have a vector coming in from our buffers, I guess. It's a vector 3, and a GL position output will be the X, Y, and Z. And one there. So what we could do is we could also sizzle that. So just put that in there. But any major industries are still placing their safest bet on either DirectX or OpenGL, while I've heard Vulkan's better using GPU. Yeah, I mean, it's probably due to, if you want to port everything from OpenGL to Vulkan, you have to spend man hours, right? You have to pay people to do it. And I guess not as many people know Vulkan as compared to OpenGL, so it costs less for companies to I guess, develop in OpenGL or DirectX. But however, Vulkan, I wouldn't say that Vulkan is not used. I mean, Vulkan, if you look at any sort of like modern game nowadays or modern engine, they will be using Vulkan for the renderers and stuff, just because of the performance performance improvements that you can get, and even like emulators as well. If you take a look at like retro emulation, things like PS2, PS3 even, like Dreamcast emulators, they all have like a Vulkan backend as well nowadays. Because as I said, you know, there are major performance improvements that you can get. You can customize more things. Okay, I mean, this doesn't look too bad for us. Yeah, let's put that there and that there, of course. So now we have the same shaders as this tutorial, and this shader is actually very easy. Like, we can go line by line here. We're just taking the XYZ positions of the triangle into the shader, and the vertex shader is basically just passing on those 3 vertices. And the fragment shader is the one that actually is going to color that triangle. You know, going to put colors in every pixel of the triangle. And yeah, it just takes on the fragment position, and then the color. It returns the color of it. So that's all this is saying basically. And down here though, what we need to change is like to get the attribute location, right? Because if you think about this as a pointer, it's not really a pointer here because you're dealing with like data in the GPU. But this A position variable will have a pointer to it. So you can get that in OpenGL with the attribute location, or GL get attribute location or something like that function, which is wrapped with Qt to just attribute location here. So A position, I think it was called. We don't care about the matrix, although we can leave it there, I guess. We can put a matrix here for now. Actually, it should be a uniform. Yeah, we can have model view matrices passed into the shaders as well, because if you couldn't, you know, you wouldn't be able to like rotate, displace, and even see things in OpenGL properly. This is all done with matrix multiplication, and we'll come to that later, but I'll explain what uniforms are. I'm just putting that here so this compiles, because we are passing a uniform matrix in there. Let's just build this, make sure it's still building before we do anything. One thing that's nice with Qt's implementation of OpenGL is that it seems to return errors and, you know, at least print them out when something goes wrong. Because I noticed that before, when I copied and pasted the code for the first time, I compiled and ran the code, and then there was like a syntax error on the vertex shader, and it did say that. So here, right, we are hitting a bot because we hit uniform location matrix M shader. Uniform. Okay, so what is the issue here? Right. Let's Google how to pass uniforms to shader OpenGL. Yeah, we just pass it with the uniform matrix, and then we... Okay. I'm not sure if we need this location thing. And also, let's up this. So 400 here. 400. So uniform map for rotation matrix. Yeah. What are we missing there? What are we missing there? So we have uniform map for matrix. Huh. Interesting. M shader get uniform location. Okay, let's build it again and see. Rebuild. So how was your guys' weeks? Did you guys work? Did you study? So I can tell you my week was quite... It was busy, I guess, but I'm really tired on the weekend though. I'll tell you that. I get really tired on the weekends now. Hence why I'm having like a massive glass of Coca-Cola. Okay, so we still returned -1 here. I wonder if this is because we haven't used the matrix in the code. So let's just use it here. Matrix times down. I'll explain why we're timesing it there later. This is just a model view matrix. I think it's called model view matrix that we create with Qt. Yeah. I was exploring LLVM. Oh yeah, it's a good project, especially if you want to get into compilers and stuff and making your own languages. LLVM can help you a lot. Right, let's see if when we use this matrix, if it doesn't complain. Yeah, it doesn't complain now. Good. Yeah, but we still don't get the triangle, right? We still don't get the triangle, and let's find out why. So at least we know that the shaders are somewhat working because they have compiled and nothing was complained about by Qt. Slim, hope you're well. I'll put this in the background while I was playing CSGO. Nice, dude. You mean CS2, right? You download CS2, yeah. I thought Valve made everyone switch already. That's kind of what I do when I'm not coding, by the way. I do play a game or two of CS as well. I've been addicted to it since I was a child. And yeah, welcome again, and good to see you back, dude. Right, what the hell? Now at least we've got the Qt or the Qt window. Let's take a look at the rendering. So clear color buffer bit. Yeah, and then we bind the shader program. So we're using that, and then we're setting the uniform there. And we've got the vertices here. Yeah, no. This is kind of wrong. This code. Man knows his priority given viewership to stream playing game. Yeah. Yeah. Thank you for leaving the stream open in the background, you guys. I mean, the more the merrier. I'm not sure if the algorithm does anything, like when people just leave it on the background, and when there's more people watching, essentially. I know that likes don't mean anything. Like, it tends to be view time now. Yeah, what we need to do is we need to actually, instead of having these vertices here, I need to pass in the buffer. I need to generate the buffer first. So let's create a variable for the buffer. This is the vertex buffer, by the way. Assign int. Let's start with 0 until we override it. And when we initialize everything, let's, you know, create a data, or sorry, request data for our vertices vector. Okay, so I was just reading a message from one of the plumbers that came in the other day. Yeah, so we need to have a GL bind buffer here, if I'm not mistaken. We also need to have a GL gen buffer as before. Yeah, vertex buffer. Let's put a QSR here, so if it's something less than 0, what does it return? What does GL gen buffers return? So GLU int, is it always more than 0? I wonder. It doesn't say, does it? Okay, so yeah, maybe we can assume that this is not going to be 0. So we can say Q assert vertex buffer is not 0. And then we combine the buffer, so GL vertex buffer. I think is it GL vertex array? And this is something that I have to look at the documentation again. That's the thing with OpenGL, like you'll never memorize everything. Never. So the GL array buffer, the one we need, okay. And then we get the buffer, which is vertex buffer, and GL buffer data. And we can say the GL array buffer. We're going to pass in the size of it. The size is going to be the vertices size, I think. Is that size in bytes? That's the problem. Because I'm not quite sure. So GL buffer data, let's have a look. So what are you guys all up to tonight, apart from playing CSGO? You guys doing anything interesting? Size in bytes, alright. So this is the size of in bytes, and then the actual date specifies a point to the data that will be copied. This is our vertices.data. And then the GL enum storage is GL static draw. And the usage, no, that's right, 1, 2, 3, 4. Okay, cool. Yeah, we've got that here. I kind of also want to get an attribute pointer. Like we've got an position attribute here. Position attribute. Like, where is this coming from? Enable vertex position attribute. Yeah, I feel like we need this. GL vertex attribute pointer. GL. Vertex attribute. GL vertex attribute. Now we need to give it a index. What is it? Specifies the index of the generic attribute to be modified. Yeah, which is that one there. And the size, we can have it 3. Maybe GL flow. That's correct. Not normalized the stride. Specifies the byte offset between consecutive generic vertices attribute. Okay, so this is 3 times the size of float, I think, right? And then the last one is going to be a pointer to the data. We can just set it to 0, I think, right? Specifies if a non-zero buffer is currently. Pointer specifies an offset into the array. Okay. So does this have to be a pointer itself, a Joe void star, right? I hope that's what it that's what we can do. No, yeah, that's cool. That's cool. Now we don't need this. Vertex attribute pointer there. Or do we? Let's do a clean rebuild now and see if we get any errors. Okay, we still got a black screen, but is this rendering function actually being called? Okay, it's called a few times. Draw arrays, okay, and then we swap the buffers maybe at the end. Shader release and frame. So I have no idea why we still have no triangle, but at least we have the same shaders as the tutorial, and we also have the data being put into the buffers correctly, right? Position attribute. Show flow flows. Maybe we can make that call on the render as well and see what happens. Nope. We still got nothing. Right, so what are we missing? That's the the biggest question ever. So what are we missing? Pact is quite nice. They've got really nice books, so I trust this tutorial. Bind vertex array. Now we've got GL triangles, draw triangles 0 and 3. Cool. This is a tutorial I watched the other day, so hopefully this is not anything with WSL, because we were already struggling last time to draw some OpenGL things in it, but so we translate down with perspective, So where is this in space? Where is this vertex supposed to be? Let's draw it out and see. So we've got the XYZ coordinates. Let's just put it here. So we've got X, Y, and then Z that kind of comes out like that. So this is Y, this is X, and this is Z, right? So our coordinate, let's say this is like 1, 1, and 1 here. No one is actually too far. So our coordinate says that hey, so I'll say rare. Hey Matt, how's it going? Hi man, how's it going? Good to see you on the stream. Welcome. We're just doing some OpenGL today. Hopefully getting a triangle to draw on the screen like we couldn't last time. It's going okay. Just the same usual, same usual. So we have -5 and -5. So -5x would be like there. -5y would be like there. So that's the first point that we've got. Like your streams, man. Thank you very much, man. It means a lot to to have people watching this. Because to me, this is just, you know, me coding and it's quite boring sometimes, but I'm glad that other people like it. And then the second point is on 0.5 minus, so it's like there. And the last one is 0.5, which will be like there somewhere. And then this, so this is the triangle that we should see if we're watching. Can we get a color? Oh, there you go. That's kind of the triangle that we're looking at right now. Now the point is, where are we looking at? Because that's the issue. Like, we could be in this code that I've copied, kind of like the camera could be here and we're looking at that direction here on the kind of origin, right? So ideally we should see that, but I'm not entirely sure. So let's have a look. What we could do as well is compare these vertices to, I guess, what we copied from. So I guess we can copy these. And then just see if these ones kind of show up. If we can find them. There. I just put a 0 on the end of the vertices because we have x, y, and z, whereas in the example we copied it from, they only have x and y. So okay, so we finished. Let's debug it and see if we get a triangle. Now I don't have high hopes. I think we're still going to get a black screen, black Qt screen. There you go. As I said, nothing much happening, but at least full screen works straight away, I guess. So yeah, this must be something we're missing. Must be something messed up that we're missing. So we've got the viewport, we've got clearing to black. We've got the perspective matrix, sorry, the model view matrix. And then we're using the shaders that we've just compiled here, and in between, when we're using the shaders, we enable the vertex attribute pointers, draw the triangles, and that should be really it. But I kind of feel like something's definitely not right, and I can't really say why. When loading the data though, when initializing the whole thing, we generate the buffers, we bind the buffer, and we set data to the buffer, and then we say that how the data should be interpreted. So M position attribute. Okay. Maybe do I have to bind the buffer again here? What was it again? It was GL array buffer. Yeah. Just quit stream so it doesn't keep telling me people online, because I'm not really playing now. Thomas, what? Hey Tom, how's it going, dude? How's it going? If you're interested in some OpenGL, welcome, dude. Problem is that it's really fucking difficult, and I don't know what I'm doing wrong here. So you should be seeing a triangle, but there's nothing in here. You see? Partly because this kind of guide is kind of probably not working, but I don't know. Yeah, sounds super difficult. Yeah, it's not as difficult as other things, but difficult enough, I guess. I'm using a library called Qt as well. That's kind of like really big, but it's documented nonetheless, so it's kind of easy to follow. And this is not what we want. We want the main file and see what they're doing here. So what are they doing here? Let's take a look. Yeah, I've got the same thing. I'm opening the shader program, compiling the shaders and linking the shaders for the GPU. So I've got that. I'm also getting the attribute locations for my positions, vertex positions. I remove the colors because we don't really want the colors yet. We just want to paint it red. And then, yeah, we've got a matrix there. So yeah, we've got the same here, basically. I think that's the issue. I think the GL vertex attribute pointer for Qt is not the same as the OpenGL one. Qt, let's take a look. And if that is the case, I'm gonna cry. But let's see. So yeah, in essence, I don't think I need to bind the buffer. What I need to do is to basically, where's their example? Just do the same thing here. So the position attribute, number of elements, float, and 0 vertices. Let's do that. Okay, let's get rid of these buffers. And let's get rid of the buffer here as well. Let's build it again. No, Tom, I don't mind at all, dude. I read your message, it's fine. The more the merrier, actually. YouTube algorithm is going to bless me the more people there are, so let's hope for that. It's crazy that I actually do get some people watching me. Like, these guys are amazing. some of these guys watch me like every 2 days. Dana J and Slim and Antonio. So thank you guys for joining. Yeah, still black screen. Fuck. So finding no GLFW and no FreeGlut. Yeah, so GLFW and FreeGlut both had memory issues. So I'm compiling the code with memory sanitizer, and both of these libraries actually had memory issues. Like as soon as you initialize them, you get loads of memory complaints. So I decided to not use them and use Qt instead. Also, Qt has a wide selection of multimedia libraries. So if you look at Qt Audio, for example, yeah, I think you can read like WAV files and things like that. So it might be, very, very useful for the for the future of this project, where I actually have to read sound files and then analyze them with like a fast Fourier transform to get the bars for the audio visualizer. So yeah, I mean, why not? I decided to switch everything to Qt. Hence why we've got this stream today, because it's going to take a bit longer than expected, I think. Qt OpenGL. Let's look at a different example, because I think I am missing something and I'm so blind to my code that I just can't spot the issue. Now this is OpenGL 2. This is OpenGL 2. Oh, that's very cool though. There's this sort of wireframe of a sphere. But they're a bit ahead of us. It's crazy that I can't even get like the most simple, the most basic example working for some reason. Yeah. And I wish I knew someone who knows OpenGL well to basically point me out like whatever it is that I am missing. Yeah, this person is following the exact same tutorial. So vertex attribute, vertices. So we've got enable vertex attribute, right? Because this function has to be used every time you load in data to the GPU. And you have to say, I want to enable, whatever was added to my my position here or something. You again release the program. The cube program. This is a better one. It has some textures in it. Following code enables depth buffering. Okay. Also, Qt has OpenGL textures, also kind of wrapped, which is good, I guess. Yeah, no, this is a little bit of what we don't want right now, because it's textures. So I'm not messing with textures right now. Size of. Are you planning to add some tests like G-tests? Yeah, maybe in the future. Yeah, when I've got some of the Fourier stuff implemented, I want to test that it returns the right data. But right now, since we're just getting the graphics sort of back end trying to work here, then not right now. But yeah, could include some G-tests in the future. Yeah, I mean, we do have a shader already. We have an array buffer and a vertex attribute pointer. Type normalize stride. What the hell happens if I just have no stride? If my stride is 0. And what happens? I want to add back the buffers here because this is how I know it should work. So gen buffers should be here. So I'll say, Rad, do you know any OpenGL? Have you done it before? You sound like you know your stuff. No worries, man. No worries. Thank you for joining the stream, though, nonetheless. And yeah, I mean, looking forward to seeing you again, dude. Have a good night. So yeah, GL bind buffers, and we've got targets, so GL buffer array or something. GL array buffer. Yeah, there you go. Let's also do a Q assert here to make sure that our returned vertex buffer is more than or equals to, or just more than 0, I guess, right? It's an unsigned value. What are we doing? GL array buffer. And the size of this would be the vertices. No, size times. This is the size in bytes, right? And just to make sure, let me look at the documentation for the Qt one. Qt from OpenGL. Convenience function that calls GL. Okay, cool. So it is the same as the OpenGL one. There's nothing funny here. So it should be the size of that times the size of the bytes, which is the float. Yeah, this is the total byte size, which is the size of my vertices, and each vertex is a float, and we have to times that by the size of the float. Up to here, that's fine. The data itself, vertices.data, I believe, right? And then this is a GL static draw. Okay, cool. Yeah, the only difference though between this run and the previous one is that we have 0 as the stride. I see some of these examples with 0 as the stride, so let's see. Even though it doesn't make sense, because stride is basically the difference in bytes between consecutive elements, so it should be like 3 times the size of float, if it makes sense, but I don't know. Maybe I just don't understand it. No, it still doesn't work. Still something wrong. And out of interest, because I'm starting to think it could be something with my WSL. So if I do, for example, if I just search for a triangle OpenGL on GitHub and try to compile it, does it work? already have all this, so let's try this one. I'm starting to think that maybe there's something wrong with my drivers. So I don't really see what I'm missing here. So let's try to compile this one. Do we just make? No such file. Lib OpenGL dev. Okay. Oops. Again, hello, colorful triangle. Yeah, it doesn't compile. Great. So this doesn't compile. Let's try a different one. Oh no, this is Vulkan example. Jeez. Let's look for the OpenGL triangle example. So the GL frag variable is deprecated. Why? Why is it deprecated? What should we use instead? Use the vfrag color. Could it be in the shader? Could it be an issue with the shader? Nah, I don't think it could, right? Let's use sample GLSL 400 example, version 400, the basics of GLSL 4.0. Is there an example here I can copy from? So we've got layout, location, vertex, okay. So GL position still exists, and it's just frag color. Let's try that here. Yeah, frag color. That's what we have anyway. Urgh. What is going on? Oh, this looks very involved. I don't really want to read this now. See, we're right now on version 4, so 400. So this is an example shader, so in vector vertex position, and the GL position is the one he's using. And he's using frag color out. What is this fragment shader? But he's specifying that we have frag color there. Yeah. So this is the minimal C code that you need to get this work. Load the vertex shader file. So into a single C string GL create shader. We do have that. We have shader source as well. This is all done by Qt for us, the compilation and the linking. So this is all done by Qt. And I can see that basically right here. So you've got like the shader compilation, shader loading, and the linking. Seeing how laborious and challenging a simple audio visualizer is, it makes me even more appreciative of people like the ones who make Quake. Oh yeah, 100%, dude. 100%. Yeah, making an sort of like an engine of any sort, audio, graphics, it's very difficult. However, you know, once you've done something, like once I get this triangle to work, getting a box or a 3D object isn't even that difficult after that. Outside of the setup is definitely, you know, very, very difficult. Especially if you get something wrong, like I did, and you don't know where it is. That's what makes things harder. Because OpenGL has basically no debugging. It's very hard to see what's going on. Call GL, get uniform with input color. Yo, I do have that. I use the program as well. The only variants you need to keep track are the index created by GL create program. Now we are ready to draw. We look at drawing geometry with GL draw arrays. Yeah, to set. Okay. And also this seems to be very difficult just because I'm doing it. If someone else who actually knows OpenGL better is doing this, they'll probably just do it in 10 minutes. So it is the person doing it more than anything else, really. Let me get shader. Okay, cool. I mean, it doesn't seem like I'm missing any of these steps here for the shader itself. So I'm 100% sure it's not the shader. I still want to get an example and kind of compile it and see if it's working. And I'm not sure if I've got anything here. Not so boring, true. It is it's true, yeah. Seems like this stream is going to be a boring one as well if I can't do anything. I was hoping to kind of fix this really quickly, but it doesn't seem to be the case. Maybe we get one of these examples and see if it works, but this is GLFW. I'm looking for more of a Qt one, really. I could also download all of this and then just kind of run it line by line and see if it works. Should we do that? So Windows RCP in the main. Yeah, I don't see why I shouldn't. Let's try that. Let's actually grab the example on the Qt website line by line without changing anything and see if when it compiles it works, if it shows the triangle. Because if it doesn't, then I kind of know that there is something wrong with my OpenGL drivers on my WSL machine. But I'm sure it will work. So I'm gonna just create another kind of executable here to test that. And I have to include Qt on this, target, include directories. No, I don't need that. So target, link libraries maybe. Not very good at typing today. So we do test and private Qt6 GUI and then Qt6. Is it GL? Can't remember what it is now. OpenGL. There you go. Now I'm just going to copy one by one. So this is main. OpenGL window. We'll see about that one now. Hey, this song is kind of shit, so I'm gonna just... There you go. I'm still stuck with this really shit like DCMA free library on Spotify, because I don't really know what I can play without getting sort of like copyright striked or struck. I think that's the right verb. This song isn't too bad. And we get the header now. Wait, no, that was the header. Yeah. OpenGL window, there you go, OpenGL.cpp. And this is the CPP, so this is what we should have had here, right? Okay, Qt application is not part of this. Let's just include it in the main CMake list and try and compile that. Now let's see what we've done wrong here in the CMake, because there'll be an error, of course. Right. Cannot find source OpenGL window. Okay, yeah. Of course you can't, because I've renamed it. There you go. OpenGL window still not found. OpenGL window. There you go. And that's CMake for you guys. There you go. Can I do a clean rebuild? Does everything build? Okay. So ideally, if you go into the terminal and then go into a build directory, build Unix SLC test. Now this fucking works. So what is it that I am doing differently? So what I could do is I could change this code slightly, one line by line, and see where the problem lies. Shall we? Let's try that, yeah. So we know that the problem isn't. The problem is not WSL. It is actually my code somewhere. Now the first thing I want to do, as I said, is turn this example into OpenGL 3. So OpenGL 3. Okay, so what do we do? I think part of the code is actually on the Q window. Whenever we create a context here, you can see there's a new context. This is the function that we have to basically change here. So this creates GL2 by default, I think. I believe so. Anyway, so what we can do is, just to make sure, I can check it out. So I can do the autoconst format. I can query what the major and the minor version of OpenGL is here, just to make sure that I'm not going to do unnecessary work. And the minor version here too. Let's build that and run this, put a breakpoint there. I am going to also change my debugger slightly, so it starts up the test. Okay. What's the issue? No, previous declaration of major, okay. Cool. Now let's run this and see when we hit this. Yeah, the reason why I'm doing this is I just want to see what version of OpenGL this example is running by default. Because if I'm not mistaken, it's around 2. There you go. So the major is 4 and the minor is 2. So it's running 4.2. So in essence, we don't really need to set it to, I guess, 3. Unless we want to make sure that it absolutely gets 3 at least, right? Oh. So I might still do that anyway. I might still do that. And this is how you request Qt to have a surface that renders OpenGL version at least 3. If I'm not mistaken, it was set version or something. Surface.set major version. We can just do set version, right? Set version is a function as well, yeah. So if I'm not mistaken, this doesn't necessarily guarantee that it will be 3.3, but it guarantees that it's going to be like the closest supported one. So it will still return me version 4. And then I can set the version on this, so m context or set surface, I guess. It was Q surface format core profile. Yeah, this is just setting the OpenGL profile. Core profile is the core profile. There's a compatibility profile as well. Okay, set surface doesn't work. Why? Oh, set format. There you go. Okay, now if we compile this and run it, I shouldn't really see any difference. I should still see 4.2 because that is bigger than 3.3 and it's a superset of that version, so it does have all the functions that 3.3 has. So I understand Qt is still going to return me that version, right? But this was nonetheless one of the the changes that we had. So I want to see if this is what broke it. That's why I'm making this change. Yeah, it was exactly this that broke it, or maybe not. Let's see. Yeah, there you go. So that is what breaks it. Me changing the version from 4 to kind of 3.3. But what do we have returned though? That's the question. So I'm gonna rerun it and just see the versions here. Is it gonna hit the breakpoint? Maybe not. Let's run it again. It just bugged out. Why is this breakpoint not being hit? It's not loaded, address could not be. Yeah, why is this not what? If I do a clean rebuild, is it gonna build me? Oh, it seems like it is. All I want to see is the major and minor version. Come on, why is this taking so long? Yeah, it's not running, and there's only one explanation. It's not starting, right? So the explanation here is that the major and minor versions are not running because something here is not causing it to run. I think it might be this one. Might be that if statement there. Ah, of course. I'm being a massive idiot. I was debugging the wrong file. That's why. There you go. OpenGL core profile. There you go. Now we get that. Yeah, so we still get the same major and minor version from the context. So why does it break? So we set the format here. Yeah. Cool. So we know we're using OpenGL 3 now. So if we bump it up to 4 now, is it also going to break? It'll be even worse. Which version is it? 4.0? Let's do 4.0. Or is it 4.2? Yeah, 4.2 is the one we have here. Let's put a breakpoint there. I do apologize, it's quite boring now. It's just me debugging, so I wouldn't blame you if you switched this off for a bit until it becomes more interesting. So major, minor 4 and 2. Okay, we are setting version 4.2. So this is the latest supported version of my machine, 4.2. But obviously it breaks the triangle because it's using OpenGL 2 logic to actually do all the drawings, right? If I'm not mistaken, that's what this is doing. So if we go to OpenGL, to the main, for example, you can see that in here in the rendering somewhere, we still have those old shaders. So this is not quite going to work. So let's begin by changing this one to a more modern shader version. In fact, we're version 4 now, aren't we? So, and there was that nice blog post that we saw. So I'm just going to steal this from this guy. Shout out to this person, Anton Jerdelan. I don't know if that's how you pronounce his name. So let me steal the shade, put it here, and do the same thing for the fragment shader. And let's get rid of this one. Okay, let's analyze it. So version 4.2, vertex shader has a vertex position coming in. What's the issue with this one? Ending the limiter of raw string not found. Yes, it wasn't found, was it? It was not found. No, it was. And this one has input color coming in as a uniform here. Okay. So the first thing we need to change is the vertex position name here. It should be that. And we don't care about the color attribute because we don't have one now. And the only uniform that we've got here so far is the input color, right? The input color is the only one we've got here. So input color. That was the British spelling. I do like this. Let's change this to a different name. Okay, we don't care about the matrix for now. Or do we? I don't know. Yeah, let's put the matrix in anyway. I'm kind of scared now. So uniform map for matrix. GL position is going to be the matrix times that. M matrix uniform. We're going to do the same thing, just save the uniform location in the shader in our class. Make sure it's not -1. And I made a typo here, should be matrix. Of course, we need to actually put it in a class somewhere. Good. Set uniform value. What does that take? Takes a value of a GL flow 3x3, 2x2. Q vector of 4D is what I want for the color. Now what can we do here? X, Y, Z, W. Okay. So in theory, we should be able to do this. What is it? Q vector fully. I set it to red. Right, and then we can include that Q vector here. Okay, so we're setting the color to always be one value, and we're setting the uniform variable to this value here. And then the matrix, we also got to send that in, set uniform. Okay. Now we've got to change these. This logic is the one that fails in this version, because if we look at the GL docs, or docs.gl, I guess, you can see that this function here changes behavior between OpenGL 2 and 4. So vertex attribute pointer. So GL vertex attribute pointer here. So we've got, let's open both of them so you can see the difference. So this is GL ES2. Is it ES that you want? No, we just want GL2. There you go, GL2 and GL4. Yeah, there you go. So the pointer here specifies the pointer to the first component of the first generic vertex attribute in the array. The initial value is 0. So what is changing there? I guess not much. So why didn't this call work between the previous example and the example with OpenGL version bumped to 4? That's my question. Let's try it. Strange, very strange. Do we have an example of this? So we enable the vertex attribute, whatever. Attribute indexes were received from calls or passed into bind attribute location. UV coordinates. So they set the stride to 0, I guess, right? So that's something we can do as well. And text chords.data. Render an indexed buffer object using texture UV and normal vertices. Okay. So let's leave this as is, because according to the documentations, this should be more or less the same. Only issues that we have free here, and the vertices, let's put it as 0f there, 0.0f, and 0.0f here as well. And we don't care about the color array for now. We don't care about this for now either. We also don't care about the color attribute. Question is this going to work? Vertex position, input color. If this works, I'm quite happy, but I kind of feel like we've broken it by now. Yeah, I definitely feel like these OpenGL streams compared to the Burst streams are really less productive, just because we get stuck on things that we shouldn't really get stuck. And I guess in Rust it's a little bit easier because the compiler kind of tells you what's wrong most of the time. But yeah, let's hope that we have at least an error here if nothing works. Yeah, we get back to the black screen. Oh, this is very, very annoying. Very, very annoying. This is very annoying indeed. Uniform input color. None of these things are failing, because if they were, the Q asserts would definitely not return, would definitely not pass. They would finish the program. So the issue is definitely on the render side, I guess. Yes, this is making the frame rotate. We do enable the vertex attribute array, position array, and we draw the triangles there. And we do bind the program there. Enable vertex attribute. And we do have that, right? We've got the enable vertex attribute position array, which is acquired from the vertex position there. There you go, the same person, Anton Gerdelan, I think that's how you say his name, has a little, at least a tutorial for drawing one triangle. So let's see if we're, compared to his tutorial, if we're missing anything, because as we established, when we switched to OpenGL version 4 here for the Qt example, things fall apart, and I don't know why. I don't know what I've done to make them fall apart. So. So he's using GLFW, he's creating the window. Okay. Define a triangle in a vertex buffer. So this is kind of what we have. We've got the X, Y, and Z vertices for each of the triangles. Something like this. So he's generating the buffers, he's binding the buffers, and he's got the buffer data. So we don't have that right now, so maybe we can add that. Yeah, let's do that. So in the class itself, one last try tonight, I guess. Which type is a GLU int? And then whenever we load the stuff, we can kind of do this. This will be the M vertex buffer. M vertex buffer. Let's do a Q assert here as well, just to know if it fails. Q assert. Just going to make sure that the M vertex buffer is kind of more than 0. I think it returns 0 if it fails. I'm not too sure, but this might be a wrong assumption. Bind buffer, okay. So points here. Where are my vertices? My vertices. Let's move them out here. And we've run out of music, so let's find another. Quickly CMake free Lofi. So it's not really awkward. Now Disney Lofi is definitely gonna get me struck. So okay, there you go. Start playing again. Yeah, that's fine. I mean, I could. Yeah, let's just leave it there for now. Vertices.data doesn't exist, so it's just vertices. Unless we want to turn this into an array, which we could do, I guess. Yeah, let's do that. There you go, still array. Okay. Yeah, so this piece of code, I mean, I'm not going to read the text, but he's just putting data into the GPU or into OpenGL. It's not necessarily on the GPU. Now, an unusual step. Most meshes will use a collection of one or more vertex. That's hold pointers, taxa coordinates, vertex normals, etc. In all the GL implementations, we would have to bind each one and define the memory layout every time we draw the mesh. To simplify that, we have a new thing called vertex array objects. We know about these because we've seen them in the last stream, which remembers all of the vertex buffers that you want to use. Yes, it does indeed. And the memory layout for each one. Yeah, so we can create a VAO as well. This will go on the class itself. Yeah. So is it GL uint? It is. Again, in the initialization code, we're gonna put this code essentially there. I did not copy. I'm gonna do one of those asserts just to make sure it's not 0, but I'm pretty sure it might be 0 this one. But anyway, why is this undefined? It is defined. Thank you. Enable vertex attribute array 0. Why 0 though? Vertex attribute array. So bind vertex attribute, enable vertex attribute 0. Why is he putting 0 here? Buffer. I don't want that. I kind of just want. I want this one here, so the position attribute. I'm gonna put a note here because I'm not sure if this one's correct, but enable vertex attribute array. Let's see how it's supposed to be used. On docs.gl, gl enable vertex attribute array in GL4. Enables or disables a generic vertex attribute array. So the index specifies the index of generic vertex attribute need to be disabled or enabled or disabled. Vertex attribute array text coordinate. Attribute indexes were received from GL get attribute location. Yeah. So this one here. So this is correct. My assumption is correct. So we bind the buffer. What is it? What is it supposed to be? Bind buffer VBO. It's supposed to be the VBO, which is what we got from gen buffers, which is my M vertex buffer. Antonio, hello Antonio. Bom te ver. It's good to see you here, bro. It's getting late here, but we're still going. We changed everything to Qt because I got sick and tired of the memory issues of GLFW and FreeGlut. So anyway, we're here now. So bind vertex array, enable vertex attribute, okay, and bind buffer. So 0, 3, float, and no. Now all we got to do, as far as I'm aware, is just to enable the vertex attribute array when we render. And this is, yeah. So we use the program, bind the vertex attribute array, and draw the triangles. Yeah, so what's the issue? Gen vertex arrays. Gen vertex arrays, GL gen vertex arrays. Let's see why it's not available in Qt. Oh, excuse me, why is this not available? It was not declared in the scope. Did you mean gen? No, I did not mean that. I in fact don't mean that. Ah, yes, of course it doesn't exist. Because if I go to OpenGL window, this is the OpenGL 2. There you go, guys. Much better now. 4.2 core. There you go. You know, maybe another reason why things weren't quite working. But yeah. And you can see that now that problem is no longer there, right? So they always do get something wrong. Automatic mock for target. Autogen. Let's see what the freaking issue is. Class name before. What is the issue? OpenGL does not name a type. Did you mean OpenGL functions one core? I don't know what I meant, you know. Let's take a look. It's supposed to be on this one here, right? Yeah. It's not a name or a class or a struct. Oh yeah, it's because I did 4.1 here, and you're supposed to be 4.2 there. Let's do a clean rebuild. Hopefully we won't get those issues now. Alright, cannot convert from const array to const GL float. Okay, so vertex attribute float. Right. Yeah, so let's see what this person has there. Well, let's just comment this one out actually. Enable vertex attribute array. When drawing, he's got the bind vertex array, GL bind vertex array. It's got GL bind vertex array, and then this will be the vertex array there. Disable vertex attribute array. Close. Okay, yeah, this is not needed at the moment. And GL enable vertex attribute array, and let's hopefully see if you if we get a triangle again. If we get back the triangle we messed up. User bin, no such file directory. What does it mean? What does that mean? Tell me the debugger didn't bug. I think it did. Yeah, I think it bugged out. So let's open the code again. Okay, let's run our test program because it should still run. Good, the debugger is back to normal now. Yay! Finally, fucking hell. That was so difficult. Why was it so difficult to convert between OpenGL 2 shaders to OpenGL 4? I'm telling you guys, it's the freaking Qt examples misleading me. But yeah. Cool, can we make this more interesting? Can we have colors on each vertex? I think we can now. That was fairly easy. That's what I mean. With OpenGL, once you have everything set up, it's much easier. Spin, 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 yeah. It's much easier to actually kind of like extend what we have. So for example, I have here on my shaders, I'm saying that I'm taking a vector 3 for the positions. What I could also do is taking a vector 4 for the color. Let's change this to position. And the matrix is, you know, what's making things rotate, so we leave that there now. We also want to probably say that we want to output the frag color for each one of those. I think in the shaders here, so we have there you go, out vec4 frag color. That's what we want. So out vec4. I'm not sure if it has to be the specific name. I don't think so. Frag color. So what we have to do here is the following. We have to change the, well, set the color for each of these vertices, and basically that's it. And the fragment shader is going to interpolate between the colors. So what is it? Frag color equals frag color. Okay, that works for me. Yeah, so now in the code, this would be essentially something like, well, we have to add another one of these, basically. We have to get the location of that variable, So this was just position, and this was color. Of course, we did change this. This was color attribute. So this was also color attribute. There. It doesn't exist because we haven't created it yet. Not only that, we actually have to somehow define the data, right? So somehow we have to basically come over here and then say these will be our, colors. And do we want it to be a vec4? No, it can just be a vec3 as well, right? Because we just want RGB. Alpha is going to be 1, so what we can do is we can transform this vector 3 coming in into a vector 4 in the shader by just doing sizzling and putting a 1 at the end there. Which means in here, this is mostly fine. Let's say the top one, this is the top one. So that's positive, that's positive. Yeah, so that's going to be our red. And then, which one is this one? This was -5, -5. This one is going to be that one. So that one, let's put it to blue, right? RGB, so this is one. And then the last one, of course, let's do green. Good, good, good. And you guys can see how you build up on top of this, because essentially what we do here is we have the vertex buffer, which is defined here. We also need one now for the color buffer, right? Or color buffer, because I am in the UK, so and all of this code here that's kind of putting data into that buffer, I'm just going to copy and paste. Ideally, in the future, we can put this into a nice little struct that will kind of just do this automatically, I guess. But yeah, color buffer. And this is exactly the same because we also have a vector 3 static draw, and we have, which one is this? This is the color attribute, right? So wherever we have our position attribute, we're also going to put another one for the color. So this is just enabling, I guess, so it's drawing the actual stuff. We don't need all of this though. Like, we can just do a big draw at the end. We can just disable both arrays at the end. But we do, however, need to vertex attribute pointer for the color here as well. And this is on the render? Yeah, this is on the render. And I've been so stupid that I realized that this is done on the wrong file, because I had 2 copies of the same file, one for the test. Yeah. Gonna have to redo most of that. Not an issue, not an issue. Not an issue at all. In fact, this is the one we want, and this is the one we're gonna open, so. Okay. What a hassle, what a hassle. Yeah, if you're wondering why I'm repeating the code twice here, Antonio, it's because like this file doesn't work, but this test does work. And I figured out what the issue was by redoing changes one by one from the Qt example. But yeah, they both look the same, but they're not. So vertex array, we need a vertex buffer, we need a color buffer too. So we need a color buffer, we need a color uniform. We no longer need that. We need a color attribute. Yeah, we do need a color attribute, it's already there. Of course, we're then going to... Yeah, we don't need a color attribute uniform anymore. What we do need is this. This is absolutely what we need. Huh? Why did it do that? Oh gosh, attribute.
What are you gonna do when hip hop goes out?
So,
Hip hop is an attitude. It's right here. It's how you feel. It's style.
and what is the color here? Yeah. Okay. Flag color is not there, so and color is also typo. This was color there. Okay. Alright, this is getting the, the variable from the shader. Now we have to actually upload all this data to the shader, I guess. Vertex. Huh? What have I done here? Yeah, this should actually be call attribute, right? This is bind buffer. So all this code is basically uploading the vertex data, and this is uploading color data to OpenGL. So we want to generate the buffers, and this one we're going to put color buffer here. Okay. So when we call data, okay, cool. Let's bring this over here actually, and then get rid of the old one, because the rest is fairly easy. We don't have color uniform anymore, so yeah, we don't have that. We don't care about that one, so let's just remove it. We do care about the matrix, and do you have any idea? It's for the hackathon, Tom. Not yet, dude. I want to see what everyone else is doing, and then I'll figure something good. I've not done a hackathon in ages, to be honest. I think last time I fucking did one was like uni, mate, or something, you know. This is pretty much a hackathon every day. You should see the I was doing some Rust web crawler that was quite fun actually. It's much more enjoyable when you can do something quickly. And in C++, I do enjoy writing C++, but like when I do like a Rust project here on the channel, it's so much quicker, to be honest, because the language is so much more modern, and the compiler is actually useful, and it tells you the errors. As opposed to this, I mean, you see me just spend like 2 hours figuring out why my changes to some example online didn't work. Do you know what I mean? Like that's the kind of shit you struggle with in C++. But you know, I really want to learn Rust, to be honest. So nice to use. Yeah, it's good, man. It's good. So that's what I've been doing at work, actually. I'm a Rust developer now, full time, with a bit of C++ as well on the side. It's very good for backend and infrastructure from the looks of it. So, I mean, I've been enjoying it at least. So we generate the buffers for the color, update the buffers, and then we generate vertex arrays. We bind vertex array to that. Okay, so this is bind the VAO. This is the data config book, basically. And then this is the actual, you know, enable the vertices data stuff here, which means we have to do the same for the color. Enable the color data stuff, and then we've got m color attribute, m color buffer. Good. And I feel like that's mostly it. So we enable the vertex array there. Let's enable the color one as well in case we have to do it. Color attribute and then draw arrays. So now if it all works fine, you guys should see kind of like what you see in the usual OpenGL like example line, where each point of the triangle has a different color. And I'm actually allowed to use this example. This file is part of the documentation of Qt Toolkit, commercial license usage, license holding valid commercial. May use this file in accordance with the commercial license agreement. Okay, in accordance with terms contained. So you may use this file under the BSD license as follows for distribution and any source code file. I need to see if I can actually upload this to GitHub. Because I usually publish things under MIT, and this is BSD. So either it will work or we won't see anything, right? That's the thing with OpenGL. Either it usually works or you don't really see anything. There you go. So in this case, we don't see anything. And why is that? It's because color attribute did return a -1 because it didn't find the color. In this case, we actually get a nice error because I did put an assert there to make sure that whatever pointer this returns isn't going to be invalid to the data, and it is invalid. And that is because in vec3 color. Yeah, and that is because why? Why is that? Why is that? Because it is definitely here. I mean, I definitely have that there. Color attribute there. What did this guy have? Bright color. Yeah, I mean, I'm just taking this example a bit further and sending 2 things instead of 1. Sorry about that. Attribute location. Let's recompile this from clean. Let's see if we still get that, because that's weird. That's weird. I mean, I'm just asking OpenGL to find this color object inside the shader, and I can see it there. So it, it does get used. So vec3 as well. Attribute location. Still not there. Still not there. Render now. Initialize. Expose. The color attribute is returning me a -1, which is interesting. This is just supposed to be a string, right? Let's see. Oh. GL attribute location returning -1. Why could that be? Usually that happens when the variable that you're looking for isn't being used. Because like OpenGL, the compiler kind of just gets rid of it, so it doesn't have a location there. But we do have it here. Is it layout location equals 1? What's the... What's this shader doing? Let's see. Yeah, location equals 0, location equals 1 in. Okay, let's try that. Let's try explicitly setting a location to each of these things. Layout location equals 0. And we've got in vector 3. Okay, let's rebuild it. I am aware that this code is ugly as fuck for now, but I'll make it better in the future. I'll abstract more things. Maybe for the next stream, I'll clean all of this up and actually have something working next time. Yeah, dude, why? Why the fuck is that? Assert mcall attribute isn't equals to 1 to -1. So this assert is failing. But why? Why? I have color and I have color there. Frag color. Let's see an example of. Actually, I've got a very good use of ChatGPT right now, which is to write me a GLSL. Write me a GL SL vertex shader that takes a vector free value for the positions and a vector free values for the color, the RGB colors, and returns the input and passes the input colors to the fragment shader. Let's see how good this shit is. Yeah, this is almost the same as, you know, what I've got now. Make it OpenGL SL 420 version. Yeah, this is giving me 330, so 3.3. Frag color and then frag color is equal to in color. Yeah, is this something to do with my output? My output is frag color. My input is color in 3. And frag color is that. So the only thing that it could be. By the way, yeah, this returned me the same thing that I wrote, basically. The exact same thing, just different names. What it could be is the. Yeah, I don't know. I don't know what it could be. Let's try that. instead of in position, we're going to rename this to vertex position, right? What do we have? Instead of in color, we're just going to rename it to color. So this was vertex position here. And this is color. Yeah. I think that's correct. Then we take out frag color. Input color. Okay. So clean rebuild. Maybe I had like a syntax error or something like that, so it was causing it to. Yeah, but if it didn't compile it, Qt does say that an error has occurred. Let's try and run this again. Ah, fuck. Call attribute is also, is it still -1? Why is it still -1? Attribute location in the program. Fragment shader source. This is like doing my head in now because I have no idea why it's returning something that doesn't make any sense. All this function should do is basically to go into my shader and find in like the location of where color is, right? And it essentially returns a pointer. Obviously it doesn't work if you've misspelled something or if you're trying to look for a variable that doesn't exist. So it returns -1 in that case. But I can see it right here. Look, layout 1, input vector 3, color. So this is mildly annoying. Is it a name? Should I do? Is it something to do with the color that's like reserved? Vec 3. Let's try it in color now. I swear to God, if it's like the if it's a reserved word, I'm gonna laugh. I'll receive the video. Well, let's run this. Oh my god, yeah. It's still -1, guys, it's still -1. Am I just being absolutely an idiot here? I don't know. Last color, I don't know what you call it, data to OpenGL shaders. I must be doing something different. So vertex shader, okay. So they have to match. First of all, they have to match, I think, right? Maybe that's my issue. Is that frag color here doesn't match frag color there, does it? Ah, I see what the hell is wrong. Remember when I said that sometimes when a variable isn't being used, then OpenGL kind of like gets rid of it when it compiles the the shader. So in this case, it's not been used, and this is why, because frag color, although I'm like returning it, passing it on to the fragment shader, the name here is frag color with a U, the British spelling. So in essence, this value here of in color is not being used, right? But if I did this, maybe, you know, if my theory is right, it will then compile, right? So we have input color. Let me just make sure. Input out color, out color. So we don't want that, and we want a in here, a vec4 frag color. Yeah, we have 2 frag colors now, so let me just do something. Let me change these names. What the fuck am I listening to? There you go. Yeah, okay, so in color goes to frag color. Does this work? If the input and the output names are the same? Let's just change it to color. Yeah, if this works, we can put this as another OpenGL thing that shouldn't really happen if they returned errors, but oh well. Yeah, Tom, what are you up to tonight, Tom? Are you just chilling at home? No. Yeah, I mean, this time it's a little bit better because we actually know that something wrong happened in the compilation, right? Input color undeclared. Let's see what that is. Input color is undeclared. Yeah, smoking and play League. Nice, dude, yeah. I wish I could do that too. Yeah, Becca's gone home, so I'm just on my own here, doing nothing. Hence the long stream. How's your work going? Have you decided yet whether you're gonna stay? I forgot to ask. Oh. Sorry, we can actually chat on WhatsApp about that, I guess. It's compiling the shaders, and now we have matrix uniform. Yeah. So matrix uniform, we don't need it. Oh, we do need it. We do need it. Right? Yeah, we do need it. Of course we do need it. There you go. Sounds nice. Uniform map for matrix, and then this should be matrix times that. Somehow I got rid of the matrix uniform. And it's black again. It's black again. And we've broken it again. That's fine. We'll fix it, I guess. Dude, I'm gonna probably go after I fix this shit, because, dude, this is draining mentally. Mentally draining. So now it's something with loading the shit, right? So I'm doing something wrong here. So the colors seem right. For each vertex we've got a valid color. Now we have in color here, which is the input color. Right? Is that correct? Yeah, input color is coming in. We have the matrix, location, and we're generating buffers for the vertex and the color. So we've got vertex and color buffers. We generate array objects for it. Static draw. So the data is being loaded. Data is being loaded, and bind VAO. So we generate the vertex object array, thing that remembers the layout of the data. We bind that. We enable the vertices array. Okay, let's look at this one. Okay, yeah, it's probably my bad. GL bind buffer. No, this is M position vertex array, vertex buffer. And we kind of do the same here for right. Enable vertex attribute. Oh yeah, this is wrong. This should have been M color attribute. Now with a bit of luck, we got it right. Yeah, still black. We got it wrong. We got it wrong. So what could be the issue? We definitely have the bind buffer there. Enable attribute array, vertex attribute array. Bind buffer. then we set the vertex there. This is still wrong. Wait, what? I changed it. This is... I could swear I changed that before. Yeah, basically I'm passing the wrong thing to GL enable vertex attribute array. I'm passing the buffer instead of the attribute object itself. And obviously there is a difference, otherwise it would work. Still something wrong. Times like this, I kind of wish I had a friend who fucking knew OpenGL or something. Get into a Discord chat and then just do all these things in 10 minutes. There you go, Tom, you need to step up so you can help me out on this. That was just a joke, by the way. Don't get yourself into this. It's... Vertex, okay. Vertex buffer. Draw free arrays. The matrix times the locations 1 and the flag color is there. Yeah, I've absolutely no idea what I did to break this. So bind vertex array. I'm going to enable both of those. We set a matrix after every kind of frame. And then we enable the arrays. Of course, we get the data before we generate the buffers here. We got the color data. Yeah, no idea what's going on here. Could legit be a problem in the shader now. But I'll keep pushing. So the GL position is the matrix times the vertex position. Vertex position is here. It gets stored in position attribute. And the input color also goes to color attribute. Alright, there's an error here, definitely. Array. It should be those. No color. Should be the same, 3 and 3. 1 and 1. what does vertex attribute pointer do again? Let's. How should it be called? That's my question. I know what it does. GL vertex attribute pointer. Maybe it's an example here. GL vertex attribute pointer. We have to enable it. Have to enable all of those before we set them. So are we doing that for the color? Yeah, we are. We've got all of the enabled ones here. If the last element is null, what does it say? Specifies an offset to the first component and target. The initial value is 0. If pointer is not null, a non-zero buffer object must be bound. GL array buffer. Otherwise, an error generates a pointer. It's treated as a byte offset into the buffer object data store. The buffer object GL array buffer binding is saved. Okay. When a generic vertex attribute array specified, size, type, normalized, tried, and pointer are saved as the vertex array state. In addition to the current vertex array buffer object binding. Okay. This implies that you have to bind the buffer before you set its properties. So enable vertex and then okay. Let's add these disables now. Still be a black screen, I think, but this is so annoying, so annoying, so annoying. Buffer there. I don't think there's much point in staring at this on the stream and wasting everyone's time, so I'm probably gonna call it off now, guys. But thank you all. If there's still anyone watching, thank you all for the game. And oh, sorry, thank you all for being here and watching me. And yeah, I guess we'll see each other tomorrow, maybe, when I fix this. But yeah, if you're not yet subscribed, please subscribe. And yeah, thank you, Antonio. Have a good night. Ma buona noite, cara. And tomorrow we'll fix this so we have the multiple color triangles. I'll make sure to do it before I get to the stream. But yeah, have a good night and bye bye, guys. See ya. Bye bye.